Going to go ahead and get started. I'm sure we're going to have some more attendees join us as we get started here. So again, this is a webinar presented by Alberio and EYP on energy services for mission critical data centers. I'd like to take a moment at the top of the webinar to introduce Alberio and EYP. Alberio is a leader in smart building integration. EYP is a leader in data center design. So there's a lot of synergies between what both of our organizations are doing. I was brought on about 8 months ago to lead the data center initiative, which is one of our key verticals. And more recently, Rick Einhorn, who is a managing partner at EYP, was brought along to the Alberio Energy Board. So in addition to all the synergies, there's an informal partnership there and a lot of thought leadership that goes into what we're doing today. So with that said, I'd like to introduce you to the presenters on our panel today. Over 100 years of experience in the data center and energy industries. Scott Wilson, CEO of EYP, has 40 years experience in mechanical systems design. He has held several roles in the company, including Director of Engineering and CEO. Rob Myers, Senior Associate Strategy at EYP. Rob has over 20 years of data center experience, comes from Hewlett Packard, where he was a data center facilities consultant. Rob now leads the EYP Facility Strategy Group. Rudy Bohens is the Director of Energy Services at Alberio. Rudy has over 10 years experience in the energy industry. Rudy was an energy manager at Johnson Controls and is currently the board member at New Jersey Association of Energy Engineers. Rudy now leads the Energy Services Group at Alberio. And myself, Matt Caldwell, I'm Vice President of Data Centers. I have over 15 years experience in the data center industry, most of that is account management. I was a government account manager at Schneider and managed Hewlett Packard globally for Siemens. I'm now leading the data center initiative here at Alberio. And last but not least, John Harnett, VP of Energy Procurement at Alberio Energy. John has over 20 years experience in the energy industry, coming from Constellation, Enernoc, and is now Senior Vice President of Sales at Alberio Energy Procurement, coming over to us from the recent Taylor Consulting acquisition. So we got a lot of content to get through today. We're going to get some intros of our respective organizations. Talk about high-level industry trends and designs in the data center space, get into energy services both on the supply side and demand side of energy services, and then finally get into the process of identifying savings and the funding to get those projects going. Throughout the presentation, if you have any questions, feel free to type those in the comments section, and we'll address those throughout the presentation and at the end. And at the end of the presentation, we'll give 10-15 minutes to open up the lines. And if you have any questions you'd like to ask then, we'd love to engage with you at that point. So let me just start by giving a brief overview of Alberio Energy. We're a vendor-agnostic integrator of BMS, EPMS, fault detection and diagnostics, and supply-side and demand-side energy management services. We take a consultative approach to smart building solutions throughout the facility. We have offices in Boston, New York, New Jersey, Maryland, Delaware, Pennsylvania, and San Diego. So given that geographic coverage, we have the ability to execute data center projects throughout the country. We have a lot of experience, particularly in the New York, New Jersey area with financial customers, but we've executed data center projects throughout the geography and can support you wherever your projects may be. So with that said, I'm going to hand it over to Scott to give an overview of EYP.
Thanks, Matt. Our services are represented here in the 5 box. We start on the left. Strategy is early engagement with customers to help them take their IT strategy and their interest in cloud and colo and help them plan for facilities over the life cycle of their business. So this starts with talking to them about their needs and interests. We help them understand the financials associated with the cloud and colo, and in many cases end up with a power, space, and cooling roadmap for them. Design services is what a lot of people recognize us as. We have a lot of credentials in that regard. Implementation is something we've been doing for the last 10 years, relates to smaller modular type projects in a turnkey fashion. Commissioning is another hallmark of our business. We've been well known for commissioning for a long time. We've augmented this normal commissioning services with forensic failure analysis and operational consulting as well. And then finally, engineering services is something that we've implemented all along our life cycle, relates to sustainable design when it comes to building designs, and is an integral part of our work and allows us to partner well with Haberio. These are some of our accomplishments. I'm not going to read through these, but represents almost 20 years of experience in critical facilities design and consulting.
All right, thanks, Scott. Rob, I know you're on the line. Could you talk a little bit about some of the high-level trends taking place in the data center space?
Sure. Well, actually, the biggest trend we're seeing today is cloud adoption, the new fancy buzzword that everybody's using. But in reality, everybody is actually going to the cloud in some form or another. Most enterprises are using Office 365 and Outlook, and that's already using their Azure cloud as software as a service. The typical trend we're seeing for applications that move to the cloud, would be like enterprise email, CRM applications, ERP apps, transactional applications, high batch processing apps, and human resources suites are the general applications we're seeing most enterprises move to. But it's interesting because we're even seeing enterprises that have a very solid data center portfolio with capacity even still available moving to the cloud. And there's various reasons for that. One of the biggest environments we're seeing them move is the test and development environments. They don't have to purchase hardware specifically for those environments, and it truly becomes just an OpEx model. There's also could be a cost savings, but again, that has to be applied correctly. You can't just dump everything in the cloud and operate as business as usual. It could actually end up costing you more. You get scalable compute resources and storage, so you don't have to just purchase hardware for your maximum usage. You can purchase hardware for kind of trend use and burst out up into the cloud. You can quickly make high availability deployments. And there is actually increased security, which was something that a few years ago wasn't necessarily the case. I mean, it might have been increased security, but the industry wasn't very comfortable with it. Today, the security, it still depends how you set it up, but the security tool sets are there. And we even have main banks that are actually using the cloud for many of their environments now. You get the pay-as-you-go, and you don't really have to worry about IT and facility architectures. You just focus on the app and the application itself. But we are also seeing enterprises bring back some of their environments back in-house. And the typical rationale for this is inadequate governance. If they just open it up to anybody, self-provisioning can go a little crazy, and suddenly you have tons and tons of servers out there that aren't really being brought back down. Features in the private cloud and the public cloud do differ, so they might want to have a hybrid type of environment. Chatty applications, again, if you don't analyze your apps properly, the data transfer costs between the cloud and the on-prem applications could be very high, so they end up bringing that back until they can possibly rewrite an application, which also leads to legacy applications that don't necessarily work well in the cloud. Refactoring those applications could be extremely costly, and there's usually a loss of legacy code expertise. So sometimes it's looking into actually replacing the app with off-the-shelf type of product. But in general, the key takeaway from this trend is that data centers are still going to be necessary, whether they're enterprise-owned or hyperscale provider-owned. The cloud is still run from a data center. The two consistent items that we see is that reliability and cost effectiveness for the enterprise is really what the drivers for where they're going to host their data and deploy their applications. So for the foreseeable future, there's going to be growth in hybrid solutions, and therefore there's going to still be a need for an enterprise class data center and needs for hyperscale class data centers as well.
Great, thanks, Rob. And in this hybrid cloud environment, what are some of the design requirements that are taking place, Scott?
So since we're talking about energy today, I picked a few high levels that impact energy efficiency. There are certainly a lot more differentiators between the design requirements of the traditional on-prem or enterprise data center versus cloud type colo data center. The first is most of what we see in enterprise is a tier level, uptime tier level 3, concurrent maintainability or better. Sometimes the tier 3 is augmented with some higher level performance requirements. In the colo or cloud space, we see a more aggressive look at the design requirements. Clearly, they're driven by their customers, but oftentimes we'll see something that might be called a tier 2++. That is not an uptime designation. It's just here to indicate that it's very close to tier 3. As Rob indicated, on-prem data centers may need to accommodate change in terms of moving applications back out of the cloud or incremental changes in both directions. And so incremental capability and growth is still an important part of the enterprise data centers. For cloud and hyperscale, they often need to operate at much larger scale, but still incremental, as it aligns with their business plans. And then what's crystal clear is that both type data centers, the customers are asking for energy efficiency. And in many cases, we see the hyperscale folks being more aggressive in terms of finding energy efficiency opportunities.
But Rudy, why don't we skip over to the demand side of the equation, and can you talk about some of the energy conservation measures for the data center space?
Sure. And what we're really focusing on here is the existing buildings, working with mostly existing equipment. We haven't focused on any major mechanical or capital improvements in this list, although depending on the customer, that may be a need. Some of the things we look at on the chiller plant side for water-cooled solutions, adding VFDs wherever we can, chillers, pumps, towers, whatever's not there already, and then maximizing those VFDs through better control and more sensors. We also look to do partial and free cooling wherever possible. That allows us, to shut those chillers down whenever we can. Part of that comes to the rest of this, having the whole building act as a complete system so that we can raise temperatures on the chill water side. In thermal optimization, we're looking more into the actual racks and data halls. So we're looking to monitor temperature, where it's necessary on the in-rack temperatures through wireless sensors, feed that back and utilize more controls to manage the crack units more efficiently. In that, with the crack management, we can do staging and optimization on, having a large suite of those work together rather than controlled individually. Look to add VFDs, ECM motors wherever possible. And then again, airflow monitoring to ensure we're getting the right temperature air in the right space. Make sure there's no barriers to airflow or anything like that. Where we can, we look at airside free cooling in addition to the waterside free cooling, or instead of. This may not be possible on some of the existing setups, but that is becoming a bigger trend. And then we look again on the enhanced controls on the crack units. And one of the things we're starting to see a lot of is the fault detection and diagnostics, and a lot of that being done automatically, taking all of this information out of the various systems, compiling it into a single space, and then making useful recommendations from that massive amount of data. Some people are starting to do this, or they've maybe been doing this for years on a more manual basis. These systems allow us to take information from the building automation system, the electric power monitoring, compile it all together, and look for anomalies in all of that equipment, and do that on an annual, on a normal basis.
Thanks, Rudy. So, Scott, anything from the EYP side of the house as far as what Rudy said on energy conservation measures?
Sure. From a design perspective, probably one of the most impactful things is to raise the supply air temperature. There's changes with IT equipment that permit it. There's a better understanding, I'll say, of the benefits of considering higher air temperatures in your data center. This is the inlet air temperatures to the IT. One method that we use to help facilitate that is to make sure that the cooling plant that serves the data center is separate from the one that serves people spaces. And so therefore, you have the opportunity to raise the supply air temperature. So that, in concert with economizer brings more free cooling, if you will, hours, increased energy efficiency, and it can also include reducing your cooling plant from a mechanical cooling standpoint. Evaporative cooling solutions are more and more present. Over the last couple of years, that's both direct, which means the air is coming right into the data center, or indirect, where the evaporative cooling takes place through a heat exchanger. We see those as very common and provide a lot of energy efficiency. They can provide a lot of energy efficiency. And finally, containment. It brings a lot of benefits, but from an energy efficiency standpoint, it helps you reduce your fan energy. This slide is one to kind of accentuate, the commentary about supply air temperature. What you see in the slide is across the bottom are different climate regions as defined by ASHRAE, and on the far left is hot and humid. The four lines present relate to the ASHRAE air classifications for cooling, so that's temperature and humidity brackets. And what this is showing is the energy consumption, where the blue line is the recommended conditions, which we most often see in data centers. The red is the A1, which adds another 9 degrees on the high temperature side. And the important, and then the green one, or yellow, is A2, and then A3 and A4 are actually kind of blended into that bottom line. The important thing to see is that the energy benefits of increasing the supply air temperature as you depart from recommended and approach to A1 numbers is dramatic, and you don't need to go much further than that either to take a lot of energy benefits. And so supply air temperature consideration to letting the supply air temperature increase is big. This is representative in a water-cooled chill water plant, but the same is true from the air side economizer standpoint as well.
Great, thanks, Scott. So, Rudy, can you give an example of a time that Albireo has found and implemented energy savings in the data center space?
Sure. Yeah, one of our prior projects we had done was for a data center that was near capacity and already had some of the before mentioned ECMs in place. They were using a lot of energy. They had a lot of CRY units and already had VFDs on those. So our solution was really looking to utilize what was already there, but optimize it, take a little bit of a different approach in how it was controlled. So we added wireless temperature sensors within the racks so that we could make sure we had the right temperature in the right place, and we used the feedback from those sensors to turn down the existing VFDs and control the chilled water valves on each one of those units and reduce the chilled water usage there. As you can see on the right-hand side, it saved over 3 million kilowatt hours annually, and it had a payback of less than 18 months. It was a project here in New Jersey. We have some pretty good rebate programs. This was a custom rebate, which required the state of New Jersey and the New Jersey Clean Energy Program to review all of our calculations, our measurements, our pre and post situation, and they brought that project down to a 1-year payback.
Great, thanks, Rudy. So Scott, from the EYP side, any examples?
I have one here that kind of relates to a lot of what we're seeing these days. This is similar to one of our current projects. In this case, it's incremental units, so these units would have whatever cooling is required internal to them. So then you expand by virtue of adding units. There is no central plant. This is a flooded room type cooling design, so the supplier of temperature leaves the unit, comes down in the plenums that you see there in the middle in this case, and then floods the room with the cooling air. Hot aisle containment then takes the air as it leaves the IT and brings it up to the ceiling plenum and back to the unit. This type of design can be implemented both, as shown here with rooftop units or with the equipment on the grade adjacent to the building, and feeding the flooded room and returning back this return plenum in a similar way. When it's applied at the perimeter of the building, it kind of drives a long, narrow data center configuration. When it's applied on the roof like this, it allows more flexibility in terms of the shape of the building and how you might expand in the future. In this case, it's indirect evaporative cooling units. They're very high efficiency. It's incremental and it's energy conserving.
Great, thanks, Scott. So Rudy, can you speak to the process of identifying energy conservation measures in the data center space?
Yeah, and that's a big part of it, is that we want to take a stepped approach to this, make sure there's frequent checkpoints, and that everybody's moving in the same direction. And that all really begins with, an understanding of where the energy is going, how much is being used, and what the goals of the project are. So that starts with actual utility bills. Not only they tell us the cost of energy, the amount consumed, but it also clues us into what rebates and incentives, what type of funding may be available, whether through the state or through the actual utility company. Once we complete that analysis, we'll review it with the customer, go through the goals, whether that's a specific project that needs to be done or if it's a financial criteria. Oftentimes we're looking for 1, 2, 3-year paybacks. We'll go through and do a memorandum of understanding. And that really allows us to dedicate time, energy, and go through and do a detailed audit of these facilities. And that is really a highly customized audit for each site. We do have standard tools and templates that we use, but it's a lot more depth than a standard ASHRAE 1 or 2 audit. We're going to inventory equipment, assess the condition, look at how everything's functioning individually and as a whole, develop a whole list of energy conservation measures, capital improvements in some cases, and then estimate the project costs, incentives, and savings. Excuse me. So we'll have some checkpoint meetings in there as well, and ultimately we'll finish with a excuse me, with a with a final scope and a financial solution.
Great. Thanks, Rudy. I know those highly customized audits are important in the data center space. So, Scott, can you talk about the value of recommissioning the data center?
Yes, we're seeing a lot more interest in this. It's particularly important after a significant change in the facilities, but it also is complementary to some of the things that Rudy was just talking about, changes in terms of controls, updates related to perhaps equipment controls for replacement equipment. But in any case, it helps you make sure that you achieve the performance results you wanted, uncover any hidden issues that may restrict energy performance of the change, and make sure that your facility is on track and expectations can be accomplished.
Great. Thanks, Scott. So, Rudy, can you talk about the energy rebates that are available for data centers?
I will do my best to make it through. These are, each one is specific oftentimes to the state or even the utility that you belong to. Here in the Northeast, we have the New Jersey Clean Energy Program, does the entire state of New Jersey. Con Edison has rebates for New York, and NYSERDA covers the entire state of New York. Massachusetts, they have Mass Save. Others are based on each utility. So this is part of the service that we provide, is to get the utility bills, investigate all of the incentives and funding that we can get based on where the building is located and what types of projects we're doing. One of the places we start is this national database of incentives, Desire USA, and that is a good starting point for what's available, what codes are relevant, what grants are out there, and then our team of engineers works with each program manager for these incentives to make sure we're filling out the applications correctly and walking our projects and our customers through the entire steps of the process. Filling out the applications, doing site visits, and then closing out the rebates so that our customers get as much money as possible for their energy efficiency projects.
Thanks, Rudy. So once all the rebates and incentives are exhausted, if there's still capital funding that's available or needed, what are some of the sources that are available?
Sure. And a lot of this, in addition to energy efficiency, is a financial solution. So, in general, third-party leases are always out there if needed. But some of the things we can also do is utility bill funding, service contracts, or infrastructure as a service to move these costs from capital budgets to operational budgets.
Okay, thanks, Rudy. And I know we had some technical difficulties early in the call with getting John dialed in, so we're going to circle back to the energy procurement side of the presentation.
All right, John, give us just 1 second here. We're going to see if we can get you on here again. Oh, where are we going? Let's see. John, are you there? You should be able to.
Can you guys hear me now?
We can hear you.
Can.
Ah, wonderful. Technology is a great thing when it works. So actually, going last now actually helps out a lot, because a lot of the strategies that we develop around energy procurement and what you see here on this cycle chart of the different services that we offer on our procurement group really focus on understanding where you are in the stage of your data center. And so all the different work and the services and the rebates and the efforts that we make on the demand and management side of this scope really help play into and develop the strategies that we see when it comes to buying a third-party contract. So in specific deregulated markets around the country, you clearly have a choice as to the supplier and the rate that you pay for your kilowatt hours of electricity. So what we try and focus on in our procurement group is understanding what that load is and really trying to maximize the value of your spend in a way that's risk mitigated and works for a product that is at the proper stage of where your data center is. So as we move into the different product selections and we kind of double click through that supply strategy piece, we'll get into really the 4 products that are available to you in a market. So what Alberio tries to focus on, and what Taylor Consulting was a part of for a long time, was going through a process by which we're trying to define the rate that you pay per kilowatt hour. And in that market, if we move to that next slide, in that market, what we want to look at are products that are budget-centric and a fixed cost for electricity, or coming into a more layered approach, which actually stages the procurement process with the stage of your data center. So if you're just coming out of the ground and you're adding customers in and your load is going to grow over a period of 6, 9, 12 months, we move more towards a layered product, that more indexed product. And really what we try and do is assess the risk that's in the marketplace, whether we're at a high point or a low point in pricing, And then we're going out to bid to look at an independent, transparent way to evaluate suppliers against one another. So what Alberio Energy is supposed to do is look at 8 or 9 suppliers, 2, 3, 4 terms in a contract, and then help you guys sort of manage your actual spend over the course of the near-term future. With each of these products becomes a very different level of risk and opportunity, and really what we're trying to do is define what those risks and opportunities are for you to enable that your budget is being met and then measured each individual month. So as we look at the overall energy market today, you'll see, as we move into the next slide, is we see that the different sort of pricing opportunities that exist in that energy market. So what you're looking at here is a real-time cost of energy up in Massachusetts. In many of the markets that the folks listening are in, these prices may look really expensive to you. Up in Massachusetts, we have a very high cost of power. But ultimately, what we're trying to do is match up this pricing mechanism in the market to a risk factor that you're willing to sort of buy on. And when we look at this, we're trying to take advantage of those low market periods that you see here and avoid those high costs of power. So as we go ahead and we go out to bid and look at your load, what we're running is a process that mitigates that risk and takes advantage of that opportunity. And ultimately, what we're trying to drive that back down into is an understanding of the efficiency work that you're going to be putting in, how you're actually going to be growing load over the future, the location that you are, and then the different types of management tools that you're going to do to limit your demand. So as we move back towards that product slide and we look at really the services that we bring, what we really want to do is understand from this process where you are in this cycle, and then build and construct a timeline, which we're going to go out to the market and look at helping you achieve a lower rate of energy for a longer period of time and building that buying program in. So some folks on the call may be in a contract for 2 years right now, and you're going to go in and put capital into your projects to reduce your costs in those next 2 years. We want to make sure that you're taking advantage of that capital work in the next 2 years in your next forward contract that may be coming up 18 months from now. Others that may not be under a contract may start earlier, where we're just getting into defining a budget, defining terms, going through that cycle, going out to bid, and looking at what that opportunity is. So all of these different components that we talk about end up coming back to affecting one small portion of your bill, which is the rate that you're paying. And our job here is to really help mitigate that rate, reduce that rate, and then sustain it over a period of time. There are a number of factors that come into the marketplace. There's many different things that are very local to energy. Just like politics, everything is within the state that you live in. So for the folks that are a national-based customer, we're trying to define a national strategy. So if we move to the next point here, what we want to look at is defining that national strategy and then locally executing a contract. In the Northeast, whether it be New York, Massachusetts, Maryland in some cases, the ancillary costs around power right now are increasing. That means that the utilities are increasing their tariff rates of that delivery cost and the surrounding cost of energy, while the cost of actual physical energy is declining. So we have this mentality right now that we feel like the energy costs are declining over time, yet our bills are not reflecting that in what we're going out to bid on. So when we look at that, we're trying to actually manage that cost, build that product, and really build a process that comes through it. In our procurement group, we want to look at things like demand response as an option to mitigate that peak. We want to look at the renewable portfolio standards or sustainability goals that you may have within your company and try and bring that in and encapsulate that to your actual procurement effort. Each one of these items has a marketplace that's available to you. And to our earlier point, we really take an agnostic opportunity to go and match you up with the best supplier and the best rate that's possible. And each one of these suppliers is going to have a different position on each one of these data points. So we look at different things that will affect your budget. We try and get out in front of that actual purchasing price. But really what we're trying to do is drive a consistent process to how you buy and then maintain that process over the lifetime of that contract. So ultimately, the synergies between the demand side management, the efficiencies, and the capital work that you're putting into your data center is then being monetized in that next third-party supply contract.
Okay.
Over to you, Matt.
Great. Thanks, John. Thanks for everybody for sticking with us as we experienced those audio issues earlier in the call. So that's it for the content that we had. We covered a lot of ground here with high-level design trends in the data center industry. We covered supply-side energy procurement and demand-side energy conservation measures. So what we're going to do now is we're going to open it up to any questions. We did have a couple come in along the way. So Rob, if you're still on the line, one of the questions was PUE as it relates to new construction and existing data centers, mainly around, what are the targets that people are aiming for nowadays?
I would say the typical target is between 1.2 and 1.4. The federal government is put kind of a mandate out there to achieve and maintain a PUE less than 1.5, so that's kind of a published target we're seeing.
Okay, great. Thanks, Rob. And the lines are open right now, so you just have to unmute your phone if you have any questions. And again, we've got over 100 years of data center and energy experience on the line here, so feel free to ask questions. Don't be shy.
Yeah, Matt, this is Ben Stewart. Can you hear me?
I can hear you, Ben.
Yeah, so a question. Somebody who's new to this deregulated market where you're talking about forward contracts and hedging and all this kinds of stuff, obviously you've got a wealth of experience to it. Congratulations to that. But those of us who don't, where can we go get like a real fast boot camp on this just to get up to speed so we understand the language and the mechanics of it so we can have an intelligent conversation about it?
Yeah, and I think that was the next step we talked about earlier this week in Las Vegas, Ben, was getting together with John. So I'll let John field that one.
Yeah, absolutely. Thanks, Matt. The question is the right one in the sense that, there really isn't a marketplace to where you can go out and get a glossary of terms and a process map that exists for other financial markets like this. And from our standpoint, there really is it's a pretty opaque market in the sense that you can't open the journal and find out what a retail kilowatt hour is pricing for 2 years. The utilities do a really good job of really keeping costs on a short-term basis, so you're constantly buying at a spot market. So the real answer to really where and how you can learn about it is when you go through the process and selecting the right supplier, you really want to dig in and define the terms and the characteristics that the company is trying to find, in the sense that if you're looking at long-term rates and you're saying we're building data centers here for the next 4 or 5 years, our approach is to have a consistent cost of power that we can bill back on and understand, and then you construct the RFP to go through that. And going through that process with an independent consultant that will allow you to actually learn those steps, you'll actually learn how to buy power. There's a lot of different people in the market that are just going to go out and buy a contract for you, and that doesn't actually do you any good because you're just at the whim of whatever advice you're getting. So it's really to find the right partner to sit down, take the time up front and the diligence up front to walk through what that buying process is, to understand who the third-party suppliers are, and then when you actually get into the products, to actually deconstruct them and understand what the components of them so that you can actually know which parts of that contract you can affect. But unfortunately for you, there's not a great place to go online and learn about it. It really comes through finding the right partners, sitting down, and hiring that trusted advisor.
So you got to get the bumps and bruises. It's no shortcut, huh?
Well, hopefully our experience over the years and what we can sit down with our customers and sort of outline into that due diligence process helps really map out how and where those bumps are and those bruises are because we've been through it before. So really, it's an opportunity to really construct that RFP together and go to the market together, and then once the rates come in, to really understand them. So it's just finding the right partner to go to market with.
Okay, yeah. Well, thank you. That was helpful.
Thanks, John. Thanks, Ben, for the question. Lines are still open. Any other questions out there? Okay, so I know we covered a lot of ground today. Again, some of it probably resonated more than other areas. So we're going to be sending out a survey today. Please go ahead and fill that out. There'll be a $50 gift card for Amazon that we'll give away with that if you fill out the survey, or we're going to raffle off. Our marketing director just corrected me that we're going to be raffling off a $50 gift card, not giving it to everybody. But please take the time to do that. It'd be greatly appreciated. And we'll give you the opportunity to indicate which areas of the call most resonated with you. And if you'd like us to follow up with you, you've got the resources of the 5 of us that were on the call today, plus the backstop of the full Albireo Energy and EYP organizations supporting us. So between both organizations, there is a wealth of knowledge when it comes to energy efficiency in the data center space. I would say that we're thought leaders in this area, so don't be shy about following up with us, and please go ahead and fill out that survey. I'd also like to announce that we're doing these webinars on a fairly regular basis. We're trying to do one per quarter. So I'd like to announce that the next one that we're going to do a deep dive into that conversation that John was talking about on energy procurement strategies. So be on the lookout for an invite. Everybody that registered for this will get an invite, but if that's a particular interest, feel free to email me and I'll make sure that you're on that. We're targeting late February. And again, that's going to be energy procurement strategies for mission critical data center environments. And really excited by having Taylor Consulting as part of the Albireo family. I think John just gave the tip of the iceberg as far as the capabilities that they bring to the market, and data centers being large energy consumers in high density environments. I think it's of particular interest to the mission critical community. So be on the lookout for that invite late February, and please fill out those surveys. And if you have any other questions, we'll give it another minute here. If not, we will wrap this up. All right, folks. Well, thank you for joining us today. Sorry again for all the audio issues, but I think it was a good presentation. Ben, thank you for the question, and hopefully everybody learned something.